Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. The rise of hyperscale data centers has upended computing and network equipment business models for the past several years. The pluggable optics industry is no exception and has definitely been impacted. I'm fortunate enough to have as a guest today someone who has seen that transformation from the inside. This is episode 25, and we are joined once again by Ron Horan for a new conversation. You may remember him from a previous series of this podcast on silicon photonics. In this episode, we begin our conversation with hyperscale data centers and fiber cable infrastructure. Ron attended the University of Texas at San Antonio for both his bachelor's and master's degrees. His master's thesis topic, entitled Synthetic Vision Landing Aid System, was patented as the first GPS aircraft landing aid. From 1994 to 1999, while at Compaq, he earned 15 patent awards. In 2001, he joined Broadcom Corporation, where he managed field applications engineering for the compute segment team, ran program management in the networking BU, and was a senior director of sales and strategic account manager covering the Hewlett-Packard worldwide account. In 2011, Ron moved to Luxtera, where he worked as vice president of sales before moving into the role as vice president of marketing. Luxtera was eventually acquired by Cisco in 2019, where Ron now runs product management for the Cisco Client Optics Group. If you haven't already, please subscribe to this podcast. On Apple Podcasts, you would follow us now. We're part of the Cisco Podcast Network. Check out our blog at blogs.cisco.com and search on hashtag Cisco Optics Blog, all one word, no hyphen and no spaces. You'll find podcast notes and links there too. For our YouTube playlist, go to youtube.com and search on Cisco Optics. And for product information, go to cisco.com/go/optics. And now, join me as I talk with Ron Horan. So today I thought we could talk about hyperscales. I know that you've had a lot of personal experience with hyperscale data center operators. This is something that I think has had a huge impact on the industry, and it'd be really interesting to get your insights.
Okay.
So first of all, can you introduce us to the idea of hyperscale data centers?
Okay.
What is that?
So at one point there was, basically data centers were all data centers. And, at some point, the cloud or whatever you want to call them, cloud, web scale, basically data centers became bigger. And it was driven by companies that were doing cloud services or that required these massive data centers to basically perform whatever function that they were going to perform. And so consequently, the term, I actually used to know where the term came from. I want to say it was Gartner, came up with the term hyperscale to basically define a data center that's extremely large relative to data centers. So they started using that in their analyst reports.
And extremely large meaning what? Like, was there some kind of metric that defined the size or the threshold?
I don't know. There was never really a metric, but what we're talking about are, one good metric is do they use only, multi-mode fiber short reach optics. So anything under 300 meters long is not really considered a hyperscale. Whereas, you've got some web, hyperscale companies that are using, they're using 10 kilometer links, they're using 2 kilometer links, they're using, 1,000 meters, 500 meters. So there's kind of and consequently they can't use short reach optics. They use longer reach optics, which are more single mode fiber based optics.
So they need that longer reach because just the physical size requires the longer distance of fiber optic links. Is that?
Yeah, that's right.
Getting at?
Okay. That's correct. And if you look at some of these data centers, literally a building could be a kilometer long. They're massive. They're massive buildings. They're out in the middle of nowhere, and they require tons of power and cooling, they usually buy the cheapest land they can, and they that has access to power and cooling, and then they build these data centers, and they're very large. And then they usually on one site they'll have multiple buildings, and so not only are they connecting the one building within the single building, but they're connecting these multiple buildings. And then, from that site, they may want to connect to another site, which is 20 kilometers away. So if you look at some of these companies, the big web scale companies, by the way, just so you know, I use the term web scale, hyperscale, and cloud kind of interchangeably.
I was going to ask about that. Is there, who defines those? And are they all the same? Are there any subtle distinctions?
I think
those
web
groups?
scale and hyperscale are pretty much the same thing. I think when you talk about cloud, you're actually talking about companies that provide cloud services, like Amazon Web Services, for example. Whereas like Facebook really isn't a cloud company; they're not offering web services. So the cloud, using cloud is a little bit, different from like a hyperscale. Hyperscale is probably the best term because it just basically says a massive data center. This is really what it is.
Okay. And massive, you were saying like the sheer physical footprint size is one metric, but then I would think that everything else kind of scales up with that. You mentioned the power, and just the sheer amount of hardware, because they're probably going to fill up
That's right. I mean,
build it with hardware, right?
That's exactly right. Some of these buildings have hundreds of thousands of servers. They have, hundreds of thousands, if not millions, of optics at the data center. And this is just one site, right? And they have these sites all over the world. So it does scale up. So it's and the power. Take for example, public information. Microsoft uses. They use 32 megawatt data centers. It's just tons of power, right? Mm. And so, it's the term hyperscale basically means that just massive. Think of massive everything related to data center. So
yeah. So what are some of the main challenges? Because we've talked about power on a transceiver module scale, but when you aggregate all these components together, now, like you're saying, you've got these megawatts requirements for these buildings. And we've seen pictures in magazines of a data center that's deliberately located at a very cold river, right? So they can water cool kind of naturally. So it seems like power is a very big factor in these designs and build outs.
That absolutely. So actually, I was talking to one big web scale who I'm not going to mention, and they were talking about building these big data center sites, and they said the number one consideration that they have is power. The number two is cooling, and you could kind of put those two together because you need cooling when you need power, right?
Yeah.
The third thing is fiber. And so when they talk about the infrastructure for the building itself, it's number one is power, cooling, and then fiber. And, so.
Like, what is it about fiber though? Like just.
Well, they want a data center building to last for multiple generations. So what they do is they put in structured fiber. They don't want to have to change out the fiber. They want, when they build this data center, they put the power in, they put the cooling in. And then they put fiber in as, to interconnect between really server racks and switching, really switches, right? And so it's not like every time they build a new data center, they go in and they change out the fiber. They put in structured fiber that stays there. And so they put in a lot of fiber in these data centers, and they don't want to have to go remove that and replace it every time. That's kind of why, you'll hear, people talk about in the industry multi-mode fiber versus single mode fiber, because it's kind of, apples and oranges. They're two different things, and each has their benefits and their pros and their cons. But but what you're seeing is, as a trend at least, is that more and more of the big data centers are moving over to single mode fiber. And the reason for that is that multi-mode fiber, the optics tend to be cheaper. The fiber itself is more expensive, but the optics tend to be cheaper. But the thing about multi-mode fiber is reach. So because the diameter of the fiber itself is so much bigger, the more distance you go and the faster speed you go, you get an effect called chromatic dispersion, which means that the photons bounce around inside the fiber, and they basically.
But in multi-mode fiber, there's modal dispersion as well, right?
Yeah, there's right. So you have to be able to, the problem is what that really means to the layman is that the farther you go and the faster you go with multi-mode fiber, the more distorted your signal gets. And so
that limits the reach. So it's a kind of an inherent limit in multi-mode fiber that doesn't exist in single mode.
That's right. So with single mode fiber, you don't have that problem. The diameter of the fiber is, I think it's roughly 8 times.
9.
Yeah, it's 9 microns versus 45 microns or something like that. Or,
yeah.
5 or I guess 5x difference. So you still have dispersion, but you don't have it as much because it's not, the photons aren't bouncing around inside the fiber as much. And so consequently, it's much easier to recover the signal on the other end. And so consequently, you hear people talk in terms of generalizations, but with single mode fiber, you can reach a lot further. And so, not sure how we got on this topic, but the reason it goes back to the data center and the structured fiber in the data center is because, they don't want to put in multi-mode fiber for one generation and then have to come tear all that out and put in single mode fiber for the next generation because the multi-mode fiber doesn't reach at the faster speeds. And so
that's where I thought you were going with this, because one day they know they're going to have to upgrade to a faster speed.
Right.
And the multi-mode fiber, as we get to higher speeds, it gets harder and harder to maintain the 100 or so meter reach.
Well, right. And that's
so
just for
eventually.
Yeah.
Eventually it might just run out of steam, right? So they just don't want to have to deal with that. That was my impression.
That's exactly right. And so the trend, and going back to, I was talking about trends, the trend is that you're seeing more and more, at least of the bigger data centers, put in single mode fiber and actually move, some big data centers use a combination. So they'll use a combination of multi-mode, single mode. And, they basically use multi-mode for that reach between the top of rack switch and the first tier, aggregation switch that they run into, which is usually,
like
it's more of an aggregation switch. And so it aggregates all the signal, all the links coming in from the different servers, right? And so that reach typically is 100 meters or less. And so what you'll see is that some companies will use multi-mode fiber or an AOC, which is effectively multi-mode fiber, because that's what they use for AOCs, for that interconnect. And then for, everything above that, which is from the aggregation switch on up, they'll use single mode fiber. So that's kind of how it's been going for the last, 5 years or so. But we're starting to even see that change, where now they're starting to put single mode fiber in, even for that Tor to aggregation switch interconnect, because the cost of the optics for single mode fiber optics has started to come down relative to multi-mode fiber optics, because single mode fiber has always been cheaper than multi-mode fiber. And so when you do the cost analysis of that link between between the Tor and the aggregation switch or your whole data center, then what you find out is that it actually makes sense to use only single mode fiber. And then you don't have the logistics issues of worrying about, is this a multi-mode fiber module or is it single mode fiber? What do I do with it?
So you get this uniformity.
It's uniformity, right?
Worry about multiple flavors.
That's right.
Running around.
That's right. And you can plumb the same fiber throughout the entire data center. So that's kind of a trend that we're seeing in the data center with respect to fiber. And the reason that's significant to Cisco is because, we sell both. We sell multi-mode fiber, we sell single-mode fiber, but,
the transceivers.
The transceivers, that a lot of, especially the internally developed transceivers that we have are single mode fiber based. So that helps our business.
Okay. Single mode fiber is, if I could just paraphrase, single mode fiber adoption throughout the entire data center was the idea because they know that in the future, multimode fiber, number one advantage is you don't have to worry about two different kinds of fiber running around. Number two is in the future, for future upgrades, there will be technological challenges because of the modal dispersion of multimode fiber that maybe they can't maintain the reach that we're typically accustomed to historically with multimode fiber. And they don't want to have to worry about that. So they just say, just make it single mode fiber across the board. Now we don't have to worry about advanced technology to maintain multi-mode fiber reach in the future speeds, right? So they just deploy fiber once in these huge data centers, so they don't have to rip and replace in the future. That's right. Because of some technology trend. What about breakouts? That was the first part of my new conversation with Ron Horan. Next time, we'll get into fiber cable infrastructure and the history of hyperscales. Subscribe to this podcast, and we'd really appreciate you helping to get the word out. Share this with friends and colleagues that come to mind when you think of network technology and optics. And leave a review on Apple Podcasts. We're also on all the other major podcast platforms. You may see the Cisco Podcast Network come up when you search for our Cisco Optics Podcast. That's where we live, and you can find other great podcasts there too. Also, check out the Cisco Optics blogs at blogs.cisco.com and search on hashtag Cisco Optics blog, no spaces and no hyphens. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. The next episode is part 2 of my conversation with Ron Horan. Until next time.